Hi guys, and welcome to a new video. Today I'm excited to share with you a new algorithm called polynomial regression. This is very similar to multiple regression, but you will see the difference just now. We are going to solve a problem called as lie detector. Let me tell you why it's called lie detector in some time. As a refresher, I'm going to show you that the multiple linear regression equation used to look like this, with b0 as your coefficient plus b1 and x1 be your independent variable plus b2 and x2 be your another independent variable or feature. But in our case now, what we are going to do is we are going to have a polynomial regression with b1 x, and this is a second degree polynomial regression to the power of 2 plus b3 into to the power of 3 or into x to the power of 3. So this is the third degree polynomial equation. So you will see why we are going to do this in some time. So let's get started by importing our libraries. Import pandas as pd, numpy as np, and import matplotlib for plotting, matplotlib pyplot as plt, and once you do this, select all and shift enter. Once that is done, we are going to import the data set using the pandas read csv. The name of our data set is position underscore salaries. I'll explain you what it contains. So once you select this command and run, if you double click here, you are going to get this data set. I hope it's visible. So this is your data set where this is particular position in a certain company, and the level start from 1 and goes on up till CEO, whose level is 10. So basically this is the salary. So let's say you in your particular or in that particular company, you have a manager whose level is 4 and he is earning a salary of 80,000. So in today's problem, our goal is to predict, or this particular company has hired a new guy with 6.5 years of experience, let's say, and he is expecting a salary of $160,000, and you want to know whether that he is lying or not. So you have collected this particular data, and whether you want to know whether he is expecting more or not. So one straightforward thought would be to apply a linear regression. As you can see, the data is pretty much looks like it's increasing, but you have to find out using a graph. Before that, let me store this variables. X is equal to data set. We'll use this iloc or index based addressing and all the rows, and this will be only the first column, and your dependent variable will be dataset dot iloc of all the rows and your second column. Select it and execute. Since the dataset is quite clean and it's very small, we are not going to do feature engineering, nor we are going to split it into a training and test data set, because it's only for length 10. So we'll directly apply linear regression. To do that, we are going to import sklearn. From sklearn linear model, import linear regression library or class, and initialize to a variable linear regression, or call it let's say regression underscore linear is equal to linear regression. Once initialization is done, fit the model to your data set dot fit and pass the arguments x and y. Run it. So we see that our code is run successfully. Now we want to plot this. For this we are going to use a scatter plot from matplotlib and plot it using, let's say, x comma y, and c is equal to this is basically the color you have red, and for plotting the predicted values we want to plot it as a straight line, so it is x against regression linear dot predict and pass your x, and let's give it a x label. We have levels on x-axis and plot dot y label. We have salaries, and you can also give a title, call it linear regression. So once this is done, you want to see the plot, so do plt.show, select it, enter, and you can see the plot clearly. So you have entered a linear regression, or you have fitted a linear regression model into your dataset. But if you see the dataset, it's clearly the straight line couldn't be fit. As you can see at this place, the dataset looks more like exponential growth. And using this, if you had to predict the salary for 6.5, so using this model dot predict, if you had to predict what is the salary for the level, or what is the salary for level 6, or you have created a new level saying 6.5 and you expect a salary, it is around $330,000, so which is way higher than what it looks like. So 6.5, it is way higher than what is expected. So to mitigate this problem, since it looks like a polynomial curve, we'll try to fit a polynomial model. So now we are going to see how a polynomial regression is going to fit the same data set. So to do that, this small piece of code, I have copied it, and so this basically has to do with the polynomial features. So we are going to have a second degree polynomial, then we'll slowly increase it and see how the data is going to fit. So once that is done, you can fit it to a linear regression, the same class that you included for linear regression, but just before fitting it with the values, you just have to fit transform with the polynomial regression. So once that is done, you can see how the data set looks. So this will be your x0, this will be your x1, and this will be your x square. So basically the values are squared, 4 square, 5 square. So this is a second degree polynomial, and you have the small code to plot the data. You can clearly see that this particular model fits the data quite better than your simple linear regression. Now let's see what is the value it's going to return us when we do a predict. So be careful, you have to fit the same polynomial regression and fit transform. You don't have to transform, or you don't have to fit it again, but you can just use the transform function. So 6.5 is what is the level we are looking at. So now it is much closer to what we are expecting, that is $160,000, than what our linear regression, which gave us 330, which is way off. So let's see if we can improve this by including another degree. So third degree polynomial, select all and enter. You can see it is 133, and it has gone to a third degree polynomial. So you can see that this is the cube of that particular level, and so on and so forth. You can play around with this and increase the degrees of the polynomial, but as you will see that the curve is fitting more and more. There is a chance of overfitting, but in fact not a chance, it is overfitting the data. So overfitting is the model, your model which is trained on a particular test data is fitting the data perfectly, but it is not going to fit that well when there is some other unseen data coming around. So make sure that you don't overfit the data, and you always have to see the plot and don't make any assumptions just by looking at the data and thinking that a linear regression will work for all the cases, which is absolutely not the case here, because your linear regression graph, if I have to plot it again, you can see that clearly it didn't fit the data, and you had to use a 4th degree polynomial equation or a polynomial regression to actually fit the data. So that's all guys for today. If you like this video, do subscribe to my channel. Thank you. Bye.